Name of God, dear student. In previous session we talked about the unrestricted universals and implicational universals. As I told you, we have two kinds of universals, implicational and unrestricted. We told you many differences between these two types of universals, but as a whole, unrestricted universals are those linguistic features which exist in all of the human being languages, but implicational universals are in this way. If in language the feature A exists, certainly the feature B will exist in that language. It is the meaning of implicational universals. I mean, the existence of a feature depends on the existence of another feature. Okay, I want to continue the previous session discussion. What makes implicational universals more interesting than unrestricted universals above all, however, is that they state a dependency between two logically independent parameters. As I told you, in implicational universal, we say that if the feature A exists in one language, certainly the feature B will exist in that language. We have here the dependency between two independent parameters. It is one of the features of the implicational universal. For your final exam, maybe I ask you that if in a universal there exists a dependency between two logically independent parameters, this refers to which kind of universal? You should know that it is implicational universal. You should know that. The bold text and term and their definition are very important, and you should know them. The four logically possible language types described in the preceding paragraph actually represent two independent parameters: demonstrative noun order and relative clause noun order. Each parameter has two values. The modifier, here which is demonstrative and here is relative clause, precedes, or the modifier follow the head. We may construct a table called a Tetracorrect Table that displays the two parameters as two dimensions. Dear student, another term which is very important in typology is Tetracorrect Table. But what we mean by Tetracorrect Table, you should know its meaning. Tetracorrect Table displays the two parameters is two dimensions. You should know it. Here we have Tetracorrect Table. We have two parameters, two independent parameters about the relative and noun order and demonstrative noun order, which we in this table we show their dependency, and through that we will define some other terms. When here we have such a symbol, it means that we have a tested language of that kind, and when we have minus symbol, it means that we don't have such a language. It means that we have a languages which the order are in this way. For example, if a language is a relative noun, then in that language the demonstrative comes before the noun. Both of them comes before the noun. But we don't have a language which the relative precede the nouns, but the demonstrative follow the noun. This language doesn't exist. We don't have such a language. And we have a language which the relative clause follow the head or noun, and we have languages which the relative clause follow the noun and demonstrative precede or follow the noun. This exists. The Tetracorrect Table is a useful means of displaying the empirical data of attested and unattested language types. It is unattested, we don't have such a language. And implicational universals, on the other hand, is a relation that characterizes the distribution of attested and unattested language types. The pattern in the Tetracorrect table basically matches the pattern of truth values. In the truth table, for implicational found in propositional logic, whether T stands for true and F stands for false. Here, we try to show this Tetracorrect table through the true and false table. Here, dear student, we have true and false table for implication, and here we have distribution of attested type. Please consider, for example, here the order of known and demonstrative as a P and known and relative as a Q. If in implicational universal we say that if in language we have P, then we have Q in that language. It means that if, for example, a language is non-demonstrative, then that language is non-relative class 2. Okay, the first type is if a language is non-demonstrative, in that language a relative clause follow the noun, we have such a language. Attested means that we have such a language, we saw such a language. Here, this proposition are expressed through the true and false. It means that here when we say that yes, it means that it is true. Therefore, if the P is true, means we have non-demonstrative, then we have and Q is true, we have non-relative clause, that language exists and it is true. It is corresponded to this truth table. But if the P is true, like here, the language is non-demonstrative, but Q is false, it means that that is not non-relative clause. We don't have such a language. It is false. In the number 3, if a language is not non-demonstrative but is non-relative clause, that language exists. It means that if the first one is false, P is false, but Q is true, then we have P then Q is true. And number 4, when we do the P is false and Q is false, that is true. It means that when the language is not non-demonstrative as not non-relative, it means that that language is demonstrative noun and relative clause noun. Therefore, that exists. It is yes. Here we want to describe all of this matter which I told you. The truth table indicates that when P is true and Q is false, the proposition if P then Q is false. Here describe the above table which I told you. When both P and Q are true, the proposition is of course true. When P is false, then the proposition if P then Q is not false, because it only indicates what must be the case when P is true. In logic, if P then Q is taken to be true in these conditions. The same applies to the implicational universal. If noun demonstrative, then noun relative. If a language is noun demonstrative but not noun relative, then it would violate the universal. If noun demonstrative, then noun relative. And in fact, that is the unattested type, which is the second one. If a language is noun demonstrative and noun relative, then it is allowed under the implicational universal. If a language is not demonstrative, noun demonstrative, then it can be either noun relative or relative noun. The implicational universal doesn't exclude either type. Thus, we may retitle the column title attested by the implicational universal now demonstrative then now relative with the values yes and no in the second table corresponding to true false in the truth table. Okay, I explain it based on the table. The implicational universal characterizes the gap in attested language types as a dependency between values on two logically independent parameters. In this case, which were non-demonstrative and non-relative. Dear student, here again define the implicational universal as a whole. Please summarize this for your task, and you should know that. I want to repeat it again because it is important. The implicational universal characterizes the gap in attested language types as a dependency between values on two logically independent parameters, which that independent parameters here are non-demonstrative and non-relative clause. Unlike unrestricted universals, implicational universal begin to assemble the independent parameters of a grammar together into an integrated whole. It is another difference between unrestricted universal and implicational universal. Implicational universal are central to typological analysis because they are the lowest level link between grammatical parameters. More complex universals of the types to be described in the following chapters and a deeper pattern described later in this chapter are ultimately decomposable into a set of simpler implicational universals. Another important feature of both unrestricted and implicational universal, dear student, here we will read the similarity between these two types of universal. Another important feature of both unrestricted and implicational universals is that they are universal, not language specific. Both of them are universal, not language specific. Unlike assertions of dependencies between grammatical properties in individual languages, unrestricted and implicational universal hold or are intended to hold for all languages, setting aside exception for now. In the case of implicational universals, the universal dependencies between grammatical properties may not even be apparent in individual languages taken one at a time because there are patterns of variation. Even so, since implicational universals cover all human languages, the forces that account for their existence must be operating in the grammars of individual languages. Okay, even so, since implicational universals cover all human languages, the forces that account for their existence must be operating in the grammars of individual languages. Implicational universals represent an application of propositional logic to typology. For that reason, we have the full power of propositional logic at our disposal, and we now use it to further illuminate the dependencies among grammatical parameters. Propositional logic asserts that every universal of the form if P then Q, there is a logically equivalent universal, not Q then not P. If not Q then not P. This means not. Called contrapositive. We may illustrate this with the truth table for the contrapositive of if not relative noun, then not demonstrative noun. Dear student, here you should know the meaning of contrapositive. What we mean by contrapositive? There is logically equivalent universals. If not Q, then not P. Called the contrapositive. Maybe I give you such a formula and I asked you that which kind of proposition is that. You should know that is contrapositive. It is against the positive one. Okay, here we have the truth table and proposition table for contrapositive. Here we say that if a language is non-demonstrative, then it is non-relative. If both of them are yes, then this is attested. But here, against that, we say that not non-relative, not non-demonstrative. If a language is not non-relative, it is a Q. Then it is not non-demonstrative, which is P. If a language is non-demonstrative and it is not non-relative, it is unattested. But if a language is not non-relative and not non-demonstrative, it is unattested. If a language is it is not non-demonstrative but it is non-relative, it is attested. But if both of them are not existing language, it is attested too. And here, if a language is not non-relative and not non-demonstrative, that is attested. And if it is not non-relative and not non-demonstrative, it is attested again. One can observe that the truth values for the columns headed by non-demonstrative, if non-demonstrative, then non-relative, and if not non-relative, then not non-demonstrative, are identical. They are identical, demonstrating their logical equivalence. Then the opposite of non-demonstrative is demonstrative noun, and the opposite of non-relative is relative noun. We may replace the non-relative with relative noun, and not non-demonstrative with demonstrative noun. This yields if relative noun, then demonstrative noun for the last column, and we can see that if relative noun, then demonstrative noun is equivalent to if noun demonstrative, then noun relative. We can construct the contrapositive of if noun demonstrative, then noun relative, because each parameter has two values, and each value can be treated as the opposite of the other value. This is not possible, however, if there are more than two values for a parameter. Consider Greenberg's universal tree, number 3. As I told you, Greenberg has this study 30 language, express about 45 implicational universals, in which 27 of them are about the word order. Languages with dominant, here is the Greenberg universal number 3. Languages with dominant VSO order, verb, subject, object order, are always prepositional. Okay, it is the number 3 implicational universal of Greenberg. Languages with dominant verb, subject, object order are always prepositional. And the table of attested languages that it is derived from the following. Okay, here the Greenberg find the language, the VSO language, which are always prepositional. Greenberg studied language based on the prepositional and post-positional. Based on with studying the languages with this order, verb, subject, object, he found that all of them, which were 6, were prepositional, and based on that, he said the implicational universal of 3, that if a language is verb, subject, object, that language is prepositional, because he didn't find any postpositional of this language. But if a language is subject, verb, object, that is both prepositional and postpositional. But if a language is subject, object, verb, like Persian, that is postpositional based on Greenberg, not prepositional. Dear student, Greenberg didn't consider and didn't study Persian in that among the languages. But as a whole, he said that if a language is SOV, that is postpositional, not prepositional. He found about 11 of the languages. In this example, the parameter of declarative clause word order has 3 values. Verb, subject, object. V stands for verb, S stands for subject, and O stands for object. VSO, SVO, which is subject, verb, object, and SOV, which is subject, object, and verb. Greenberg's universal can be restated as the formula: if a language, if verb, subject, object, then it is preposition. But its contrapositive is only post. If post preposition, then is not verb, subject, object. Since languages that are not verb, subject, object can be either SVO, subject, verb, object, or SOV, subject, object, verb. The standard implicational universal is a generalization over a Tetracorrect table in which 3 types are attested and 1 type is not, or is extremely rare. Dear student, the unattested is not exist or is extremely rare. The pattern of attested and unattested language types in a Tetracorrect table or larger table is the central fact. An implicational universal is a hypothesis of an inductive generalization over that pattern. There are other possible patterns of attested language types in which only 2 types are attested, or even just 1 type is attested. If just 1 type is attested, then one is typically dealing with 2 unrestricted universals, such as all languages have consonants, all languages have vowels. Dear student, here we have 2 kind of unrestricted universal. As I told you, the unrestricted universals are those universals which exist in all of the languages. Here we have 2 kind of unrestricted universals. One of them is that all languages have consonant. It is unrestricted universal. All languages have vowel. It is another unrestricted universal. All of the vowel exists in all of the languages, and consonant, both of them exist in languages. We don't have language without any consonant and without any vowel. We don't have such a language. All of the language have vowel and consonant. If types are attested and 2 are unattested, if 2 types are attested and 2 are unattested, there are 2 possible patterns. If in one pattern the unattested type are in the same row or column, it doesn't matter where it is a row or a column, since the table can always be inverted. In the vast majority of cases, this represents an unrestricted universal on one parameter. This show, dear student, if in Tetracorrect Table there exists just one minus symbol, it means that three of the parameters are plus and one of them is minus. That is implicational universal. But when here just one of them is attested and is plus and another one is minus, this shows the unrestricted universal. Maybe I show you for final exam, show you this Tetracorrect table, and I ask you that which kind of universal this table show. You should know that it is unrestricted universal, not implicational, because in implicational the three of them are plus and exist, and one of them is not exist and is minus. But in unrestricted is against that, in that just one of them is plus and another are minus. You should know the differences between their Tetracorrect table. And second parameter is in which both types are attested. Like here, if we have a languages vowel in languages, uvular consonant exists in languages, and no uvular consonant exists, but we don't have a language with no vowels. You know here that both of them are minus. This is another unrestricted universals, which two of them are plus and two of them are minus. The unattested types in the second row are accounted for by the unrestricted universal. The unattested types in the second row here are accounted for the unrestricted universal. All languages have vowels is unrestricted universal, while the two column simply know that some languages have uvular consonant and some languages don't have uvular consonant. This doesn't indicate any relationship or dependency between the presence or absence of uvular consonant and the presence of vowel, since all languages have vowel anyway. Therefore, this shows the unrestricted universal. This is not true in all cases. However, Greenberg in 1978 described the example of oral vowels and nasal vowels. Based on that, the oral vowel exists in languages which are nasal vowels, and no nasal vowel exists in that language which has oral vowel. But we don't have no oral vowels. All of the languages have oral vowel. Therefore, this is minus. Based on this table, one may formula an unrestricted universal that is stated all languages have oral vowels. It is another type of unrestricted universals. This Tetracorrect table shows another unrestricted universal in which, based on this, we can say that all languages have oral vowel. Maybe I show you that, ask you that what it means. You should know that it is unrestricted table, Tetracorrect table, and it means that all languages have oral vowel. However, this unrestricted universal may not be the best generalization from the perspective of an explanatory account of the cross-linguistic facts. Dear student, you should know the tables, and you should know that which kind of universal is that, and you should be able to describe them. The unattested type with no oral vowels or nasal vowel can be accounted for by the unrestricted universal. All languages have vowel, and the unattested type with nasal vowel but no oral vowels can be accounted for by the implicational universal. If a language has nasal vowels, then it has oral vowel. Other evidence suggests that the alternative hypothesis is the correct one. First, there is additional evidence about the relationship between nasal vowels and oral vowels that implies that A dependency holds between the two of the sort described by the implicational universal. Second, the unrestricted universal, all languages have vowel, can be attributed to the impossibility or at least extreme difficulty of articulating a speech without vowel, whereas the unrestricted universal, all languages have oral vowel, cannot be accounted for in the same fashion, since a language with only nasal vowel doesn't have the same articulatory restriction. Okay. The lesson to be drawn from this example is that unrestricted and implicational universals cannot be mechanically read off tables of attested and unattested language types. Both by their typological patterns and deeper explanation of what is going on must be appealed to in order to construct the best combination of unrestricted and implicational universal to account for the data. Above all, the choice of the correct generalization to account for the constraints on possible language types is determined by the proposed theory behind the relationship between parameters. The other pattern of two attested and two unattested types is much more straightforward and can be illustrated by Greenberg's universal too. In languages with prepositions, the genitive almost always follows the governing noun, while in languages with postposition, it almost always precedes. Okay, it is another implicational universal of Greenberg, number 2. In languages with prepositions, the genitive almost always follow the governing noun, while languages with postpositions, it almost always precedes. Okay, if a language is preposition, in that language, noun precede the genitive, not follow. If a language is postposition, the genitive precede the noun, not follow the noun. Based on this table, we can say that implicational universal of Greenberg. In this universal, which is not exceptionless, the unattested types are found on a diagonal in the Tetracorrect table. Greenberg phrased his universal as two opposite implicational universals. If proposition, then noun genitive. If the postposition, then genitive noun. This can be combined to a biconditional universals. Okay, another term, biconditional universal, which we show that in this way. It means that preposition and noun genitive are related to each other, and its contrapositive, post, and genitive noun are related to each other. The relationship between a biconditional universal and a logical equivalence indicated by this symbol is given below compared to the truth table for implication above. Truth table for implication, distribution of attested types. If P, we have P and Q, here P and Q are biconditional. You should know that. Maybe I ask you that what this symbol show. You should know that it is this show the biconditional universal. If a language is preposition and then it is noun genitive, we have such a language. If a language is preposition but it is not genitive noun, noun genitive, we don't have such a language. If a language is not preposition and is genitive, noun genitive, it does not exist. And if a language is not preposition and not noun-genitive, we have such a language. And here we consider true and false table. A biconditional universal is not the same as an implicational universal. You should know that. It is important. A biconditional universal is not the same as an implicational universal. They are not the same. For example, if relative noun then demonstrative noun is not equivalent to if demonstrative noun then relative noun. In fact, if demonstrative noun then relative noun is false. For example, in English, the true equivalent to if relative noun then demonstrative noun is its contrapositive. If not demonstrative noun then not relative noun, or if not demonstrative then not relative, as we saw above. One way to remember this is that the Tetracorrect table for a genuine biconditional universal will have two gaps in it, whereas a Tetracorrect table for a one-way implicational universal will have only one gap in it. So far, we have discussed universals that involve only one typological parameter, unrestricted universal, or two parameters, simple implicational universal of the form if P then Q. It is very important. Okay, you should know that. So far, so far we have discussed universals that involve only one typological parameter. If we have just one typological parameter, for example, vowel, all of the language have vowel, all of the language have consonant. Here we have just one typological parameter, therefore it is unrestricted universals. But if in universal we have two parameters, we have simple implicational universal of the form if P then Q. Dear student, you should know that in unrestricted universal we have just one parameter, but in implicational universal we have two parameters, if P then Q. It is quite possible to combine three or more parameters into implicational universal involving the full power of propositional logic. Okay, in the implicational universal maybe we have more than two parameters, three or more. There are two arguments for using complex implicational universal instead of simple ones. Dear student, when in implicational universal we consider just two parameters, it is impossible in implicational universal we have just one parameter. If we have one parameter in a universal, that is unrestricted universal. But when we have two parameters, we have simple implicational universal. But dear student, when we have two parameters or more than two, it is complex implicational universal. The first is that adding further condition on a simple implicational universal can remove exceptional cases, making the universal into an exceptionless universal. With adding more than two parameters, we cover more languages, therefore they are exceptionless universal. They cover all of the languages. This process can be quite useful because it may turn out that the further condition can contribute to the correct explanation for the exception to the simpler version. For example, consider a candidate universal if a language, dear student, if a language is postpositional, then the genitive precedes the noun. It is a simple implicational universal because we have just two parameters. genitive, and postposition. If a language is postpositional, then the genitive precedes the noun. It means that if SOV, then genitive noun. It is simple implicational universal because we consider just two parameters, postposition and genitive. However, there are a number of languages which are postpositional and NG. It means that they are not based on this implicational, like Persian. It turns out that in all of those languages, the adjective follows the noun. Thus, we may modify this universal to read, okay, here we have complex implicational universal because we consider more than two parameters. If a language is postpositional, then if the noun precedes the genitive, then the noun precedes the adjective. Here we have complex implicational universal because we consider more than two parameters. If a language is postpositional, then if the noun precedes the genitive, then the noun precedes the adjective. We show the complex implicational universal in this way. You should know that. Maybe I showed you this formula and you should know that it is complex implicational universal, not simple. If a language, we read this in this way. If a language is postpositional, then if the noun precedes the genitive, then the noun precedes the adjective. Equivalent to post and noun genitive, then noun adjective. This universal is not exceptionless in prior sample, since one has to include adjective noun order in the universal in order to make it exceptionless. It implies that genitive noun order is somehow dependent on adjective noun order as well as declarative clause order. Matthew Dreyer suggests that this is because the genitive construction is adjectival in character in these languages. Dear student, I think it is enough until here, and we will discuss and continue this matter in this subject in the next session. This session, this is enough. Enter this paragraph. Okay, here we show you the tetracorrect of unrestricted universal, simple implicational universal, and we told you their differences. And here in this session we discussed some of the implicational universal of Greenberg, and then we told you about the complex implicational universal, and we show you their formula and other matters. Please look at this video many times to get the point, and then ask me your question in WhatsApp. Please do its task. Dear student, for your summarization task, you can just mention the important matter, those terms which are bold. But for your final exam, you should know the details. You should know the formula, the tables, and all of the matter which I put focus on them.